I'm back, and so now here is Newton's second law of motion. Force equals ma. And notice that I put the word total on it. Another way of saying this would be that the net force is equal to ma. So you add all the forces that are acting on the system, and then that total force will cause the mass of that system to accelerate. So here are some sample questions. So if a force of 10 newtons acts on a 5 kilogram box, what is the box going to do? So first we're going to write down what you're given and what you're looking for. So we know that the mass is 5 kilograms. We know that the force is 10 newtons. And then we want to calculate the acceleration because we know forces cause masses to accelerate. So then we're going to select the formula that connects the letters, which is going to be equation 4.1. And so we're going to say force equals ma, plug in the force, plug in the m, solve it for the a, and you get 2 meters per second squared. So there's an example of how to use Newton's second law. But we also want to be able to do qualitative questions, so conceptual questions using this formula. And so here's one for you. A force acts on a mass and it causes that mass to accelerate. What would happen to the acceleration if you use double the amount of force was applied to the same amount of mass? Okay, so that a certain amount of force is going to cause a mass to accelerate. But what we want to do is to use double the amount of force. And so now you can simulate this with a ping pong ball. Perfectly safe, all right? So that you're going to get a ping pong ball and then flip it. So what is the flipping motion? So what do you think that this is? That's the force. So that when you flip it, you're going to apply a certain amount of force to the ping pong ball. And what do you think that that ping pong ball is going to do? Well, it's going to shoot out a certain distance when you do that. Now, how could we simulate double the amount of force? Well, flip it with 2 fingers and then see what happens. So you're going to have double the amount of force, and you're going to notice that it's going to shoot out roughly twice as far when you do that. So why is that true? Okay, here's our working equation, and if we double the amount of force, so that means if I multiply this side of the equation by 2, then that means that I need to multiply this side of the equation by 2. Now notice it's the same ping pong ball, so the m didn't change. So that must mean that the 2 is going to have to go with the a. So that if you apply 2 times the force, it's going to have 2 times the acceleration. Okay? All right, now for the one that you probably should not do. So a force acts on a mass and it causes it to accelerate. What would happen to the acceleration if the same force acted on it, but the mass was tripled? So this time we're going to have a ping pong ball, and let's say you got a bowling ball. All right, now don't do this. All right, so and then what we're going to do is we're going to give them both the same amount of force. So we're going to flip the ping pong ball and we're going to flip the bowling ball. So I take no responsibility whatsoever if you end up in the emergency room after flipping a bowling ball with your finger like that. But you can imagine what's going to happen. Don't do it. But you flip them, okay? And you should notice that the ping pong ball goes shooting off, but that bowling ball, it might vibrate a little bit, but it doesn't really move much. Okay? So the question is why? So again, we're going to use the equation here that the force is going to cause a mass to accelerate. But what we can do is write the equation two different times. So this one here could be the ping pong ball. So I could put a P for ping pong ball, and I could put a P for the acceleration of the ping pong ball. And then I'm going to write down F equals ma, but for the bowling ball, I'm going to put a big M because it's much more massive. And then I need to put an A next to it. So how would I represent the acceleration of the bowling ball? Okay, now what you got to remember is that 4 is going to be equal to 4 times 1, but it's also equal to 1 times 4. So if one number gets big, the other number gets small in order to compensate. Okay, because it's the same F. So this would be the same 4 up here. So 4 is equal to 4 times 1, but 4 is equal to 1 times 4. So that it's the same F because you're giving them both the same flip. So that means that the acceleration is going to be small. So this would be the acceleration of the bowling ball. So these are some conceptual type questions that you ought to be able to do on the exam. All right, so let's take a break, and when we come back, we will talk about what are scalars and vectors.